This is Anthony Navarro. This is Chapter 15 exam, video submission, question 3, Part A. Part A asks, find the intensity I of the sound waves produced by one 60-watt speaker at a distance of 1 meter. So we are given the sound wave 60 watts, and then the distance is 1.0 meters, and they want to know the intensity. Well, for the intensity, all we have to do is we use the formula P over A, which will equal to P 4 pi R squared, which would then equal to 60 over 4 pi 1 squared, which is equal to, with the calculator, 60 divided by 4 pi times 1 squared, which is equal to 4.77, which will, if we round it to, which will be equal, which we rounded to, which I equals 4.8 watts per meter square. Part B asks for find the intensity I of the sound waves produced by one 60-watt speaker at a distance of 1.5 meters. So we got 60 watts, 1.5 meters this time, which will use the same formula P over A, which is equal to P 4 pi R squared, which is equal to 60 divided by 4 pi 1.5 squared, which is equal to 60 divided by 4 pi times 1.5 squared. There's something wrong. 60. The formula is 60. 4 pi 1.5 squared. 60 divided by 60 divided by 4 pi times 1.5 squared, which is equal to 2.1 watts per meter square. Part C asks for find the intensity I of the sound waves produced by four 60-watt speakers as held by the driver. Assume that the driver is located 1 meter from each of the two front speakers and 1.5 meters from each two rear speakers. So basically all we have to do for this one is they want to know 4, so we already have 2 with the 2 speakers of that, which is 4.8 watts per meter squared and 2.1 watts per meter squared. All we have to do is add 4.8 plus 2.1, then multiply by 2 to get the other 2 speakers, which will equal 4.8 plus 2.1 times 2, which will give us 13.8 0.8 watts per meter squared. Yeah. Part D asks for the threshold of hearing is defined as the minimum discernible intensity of the sound. It is approximately 10 to the negative 12 watts per meter square. Find the distance D from the car at which the sound from the stereo can be discerned. Assume that the windows are rolled down and then that each speaker actually produces 0.006 watts of sound as suggested in the last follow-up comment. So for this one, they want to know approximately the distance. They want to know the distance. We are given 10 to the negative 12 and 0.06 watts. The 10 to the negative 12 watts per meter squared. For this one, we would use the formula I equals P over A equals P 4 pi R square, which when we flip it to get R, it will equal square root of P over 4 pi I. And then that will equal to square root of 0.06 times 4, which is from the 4 speakers that we are given, the 2 from the previous one, divided by 4 times the 3.14 times 10 to the negative 12. And then that will equal to, under the calculations, square root of 0.06 times 4 divided by 4 times 3.14 times 10 to the negative 12 will give us 1.38 times 10 to the 5th meters. And when we see this, we get 138,232 point that. So then we go 1, 2, 3, 4, 5, which is 1.38 times 10 to the 5th, because we are going backwards this way to the left, so which will be positive instead of going to the right, which would be negative. And that is question 3, video submission, part A to D.